All right, so we are now recording our webinar, The Foundations of an X-Ray Safety Program. So enter your questions as a question mode, and I will get to the questions and answer them as time permits at the end of the webinar. So I will stop sharing my webcam now and switch to a different microphone to make sure that the recording has good sound quality. Okay, I am now using the other microphone for our sound quality purposes, and we'll move along with the actual presentation today. So welcome to the Radiation Safety Institute's webinar, Foundations of an X-Ray Safety Program for Industrial Use. So today we are going to discuss the foundational elements that should be included in an X-ray safety program for X-rays that are used in an industrial setting. So this presentation is not going to cover X-rays that are used in healthcare or in veterinary medicine, as there are some other features that need to be included in X-ray safety programs for those. If people are interested in that, we can do a separate webinar on those topics. So today we are going to talk about the use of X-rays in industry. We'll go over some of the regulatory aspects that apply, and then we will discuss overall what should be included in an X-ray radiation safety program, and we'll discuss in more detail a few elements. We won't go through everything today because we only have an hour, but we'll go into some detail on some specific elements. So I think many people are aware that radiation is actually used widely in industry. This is not limited to X-rays. It may also include electromagnetic frequency radiation, lasers, the use of radioactive materials such as nuclear gauges, but it does also include X-rays. And X-ray use can vary quite significantly depending on the use that's needed. So we do have the potential for cabinet systems, conveyor systems, and open systems. And depending on the type of X-ray equipment that's being used, the requirements in an X-ray safety program can vary. Cabinet systems which have built-in shielding will have a requirement for less safety protocols and procedures than an open system where you no longer have the cabinet providing shielding to you. In terms of regulatory use coverage of the use of X-rays, there are a couple of different areas that apply. In particular, the sale of X-ray equipment in Canada is governed under the federal regulations under the Radiation Emitting Devices Act. So this covers the requirements that have to be in place for equipment that emits radiation before it can be sold in Canada. And manufacturers are required to provide the purchasers with evidence that the systems that are being purchased actually do comply with the Radiation Emitting Devices Act. Federal rules will apply to federally regulated workplaces under the Occupational Health and Safety Regulations. So federally regulated workplaces such as baggage scanners in airports, that sort of thing, are federally regulated, and those occupational health and safety rules will apply to those workplaces. For those that are not federally regulated workplace, the provincial or territorial rules and regulations are what then applies. And this really is pretty much everything that is not occupational health and safety related, unless it is a very high energy X-ray source, such as those operating at more than 1 MeV, in which case the Nuclear Safety and Control Act and the Canadian Nuclear Safety Commission regulations apply. But if you're not federally regulated workplace and it's not a high energy X-ray source, the work falls under the occupational health and safety rules of the province or territory in which the work is being done. And the terms and requirements may differ quite significantly across jurisdictions. So Ontario may have very different requirements than, for example, BC or Alberta. So we aren't going to speak to requirements of any particular jurisdiction during this talk, but we're going to talk elements in general that should be included in an X-ray safety program. So some components that should be included in a radiation safety program for use in industry can include this list. So we can have company policies, requirements for X-ray safety officers, which I will go into a bit more detail, procedures, safety rules, requirements for worker training, verification, authorization, dosimetry, security, what sort of signs do we need, what are we doing with our equipment when we're done with it, and record keeping, all sorts of things. So these all together, depending on the type of system you use, you might have a little bit or a lot in each section, but this is a good set of things to consider including inside a radiation safety program for the use of X-rays in industry. So we'll talk a little bit about a few of these in a bit more detail, and we're going to start with the company policy or the ALARA policy. So this should be a policy of the company that is outlining the company's commitment to radiation safety. It should be similar to our, quote, regular, unquote, occupational health and safety policies. It's a declaration by the company that they're committed to radiation protection, that they want to keep doses to workers and members of the public ALARA or as low as reasonably achievable. So it's an indication that it's not sufficient for the company to simply say, hey, we're a little bit below the dose records, we're good. We want to actually have the company policy state that they're doing what they can to keep doses as low as possible in order to reduce the risks to people, rather than just saying, hey, as long as we're below the limits, we're okay. And there is, with the ALARA process, the commitment that although we are trying to keep doses ALARA, there are social and economic factors that are taken into account. So we're not going to completely stop the use of X-rays in order to keep doses as low as we can. If we're getting a benefit from those X-rays, we will still use them, but we're going to do what we can to keep doses as low as possible. So that's what we should see in a radiation safety or ALARA policy of the company. We should also, in our radiation safety or X-ray safety program, discuss what is needed for who is running the program, so the person who is responsible for the safe use of the X-ray equipment. And depending on the jurisdiction that people are in, the title for this person may be different. So in different regulations across provinces and territories, it may be called a radiation protection officer, may be called a competent person, an X-ray safety officer, or something similar. For simplicity for this presentation, I'm simply going to call the person who's in charge of the safe use of X-ray equipment the X-ray safety officer. Depending on the jurisdiction that people are working in, there may or may not be specific requirements for the qualifications of this person who's in charge of the safety. So in Ontario, for example, there is a list of specialized professions who may act as the X-ray safety officer, or there may just be an indication that the person has to be competent, meaning that they have to have a good understanding of X-rays, their interactions of X-rays with materials, what the health hazards from X-rays are, how to use and operate the equipment, and how we protect people from radiation. So depending on the jurisdiction, there may be some specifications for who may act as an X-ray safety officer, but in general, we want the person who's in charge to have a good understanding of X-rays, understanding what the health hazards are, and how to use the equipment safely to protect workers and members of the public. So the X-ray safety officer's duties should be clearly documented in our X-ray safety program and may include the following list or parts of what's in this list. So depending on the jurisdiction, the X-ray safety officer may be responsible for registering the X-ray equipment with the province or territory. We may be responsible for informing workers that they are actually X-ray workers or occupationally exposed workers or whatever the wording is for the applicable regulations for the province. If they are responsible for that, then there will be duties around documenting that informed consent. There also may be a need for the X-ray safety officer to ensure worker training and qualifications are up to date, so depending on the program, do the people who are using the equipment have the required training and qualifications, and documenting what the training and qualifications are. If you're in an area where doses to workers require to be monitored, and we'll talk about that a little bit later, then it's usually the X-ray safety officer's responsibility to make sure that the doses are monitored and actually kept, recorded, and reported as needed. The X-ray safety officer may also be responsible for ensuring that the required signage is posted and up to date, that equipment is maintained, and may also be responsible for reporting and investigation of incidents or equipment failures. So if there's an incident, particularly if there's a potential for an overexposure to a person, then the X-ray safety officer's duties would be to investigate and report on those incidents to the appropriate authority. So I have a question for the audience today. We have a poll system, and I just thought I'd put out there a poll for people to see, are you responsible for the X-ray safety in your program? So I'm going to put that out and give you all a few moments to enter whether you are in charge of the safety program or not. Excellent. I see everybody's managed to figure out the technology. We've got about 80% voted so far. I'll give it just another moment for the rest to fill in. Great. We'll stop that now. I think we've got a good answer here. So it looks like about 60% of you are in charge of your X-ray safety program where you're working, and 40% are not in charge. But obviously you're still interested because you've joined us today. So we've got a good mix of people who are responsible and those who are still interested but not perhaps yet responsible for X-ray safety in the program. So that's excellent. Thank you for completing that poll with us. So those are the duties for our X-ray safety officer. They may be expanded to other things depending on the facility. But those are typical things that the X-ray safety officer would be in charge of, and the X-ray safety program should document what the X-ray safety officer is responsible for. Another thing to be included in the X-ray safety program are documents with respect to worker training and qualification. So we should have in the program a documented requirements for what the qualifications and training are for the workers, who needs what level of training, are there particular certificates that people have to use, who needs what training. For example, people who are working in the area with X-ray equipment will need more training than those who are simply working in the area. What sort of refresher training frequency is required. It's a good idea to do training on a regular basis so that people don't forget the rules and what they have to do and are refreshed. And it's also an opportunity to remind people of anything that's been changed. In addition to that, we should also have some sort of a documentation as to whether or not people or workers need to be designated or assigned a worker category. And depending on our designation, our jurisdiction, pardon me, the wording that's used for X-ray workers may be different. They may be people who work with X-rays and are likely to get a dose because of work may be designated as X-ray workers, nuclear energy workers, occupationally exposed workers, that sort of thing. Those who are not designated as that are typically referred to as either a member of the public or those who are not an X-ray that worker. And our program should have a documentation of how we decide which category workers are placed in. And if they are in one category or another, what sort of records are necessary to be kept of that designation. Should also document how you're going to inform the worker if they are designated or assigned as an X-ray worker or similar category, and what sort of method you're using to inform the person and receive in writing acceptance. So you want to keep that sort of records, and the program should document how that sort of thing is done. Very important in an X-ray safety program is our set of work procedures. So we should document the procedures for the use of the X-ray equipment. And we can either document that as a separate set of procedures, or it can be part of our X-ray radiation safety manual. It doesn't specify exactly how we want to separate them out, but we need to have those documented. And there's various things that should be written down. So who is involved in procurement of new equipment? Is it simply the procurement people, or does the X-ray safety officer have to be involved? What sort of approvals are needed? What sort of documentation is required for purchasing? When we're purchasing, what sort of authorizations have to be approved? Do we have to register our new equipment with the regulator before we can use it? That sort of thing. All of that should be documented in our procurement procedures. Then we also should have a list of authorized users. So our procedures should talk about how we allow people to use our equipment, who is allowed to use the equipment, what sort of documentation of their training is necessary before they're allowed to use. Then we should have a set of procedures on how to use our equipment, what is to be done when the system is used, what sort of safety measures are going to be in place, are there particular safe work habits that people need to follow, do we have defined system parameters that are used in certain situations, and when do they get changed. Should also talk about protective equipment and clothing. What type of equipment and clothing needs to be used? Do we need lead aprons, gloves, glasses or face shields, etc.? And if we do, we should talk about where that equipment is stored, how it's stored so that it's still maintained in usable order, and how we're maintaining it. So is there routine work that needs to be done for our protective equipment and clothing to make sure that it's still suitable for use and for our protection? Safe work habits should include, an awareness of where our X-ray beams are, whether there's scattered radiation fields, and how workers would use time, distance, and shielding and minimize their X-ray on time in order to keep doses ALARA. We should document what signs are required and where, how often do they need to be updated, what has to be on the signs, whether or not dosimetry is required to be worn by people, and if so, who has to wear it, how is it tracked, where is the information kept, how are people informed of what doses that they've received. That's actually a fairly important piece, is to let people know how people are informed of their doses, and this tends to be missed by certain areas that are working with X-rays, because if it's not immediately obvious that somebody got a dose, we don't tend to report on it, but people who had a dosimeter and didn't get a dose are still quite interested in what dose that their monitoring systems did show. In addition to those other procedures, we should also have procedures about maintenance. So what maintenance is required for our systems or our PPE, our protective equipment and clothing, and at what frequency. So how are we doing it? Movement. If, depending on the type of system and the registrations we have, we may or may not be able to move the equipment with or without additional approvals. So we should have a document explaining, can we move the equipment? If so, what extra testing do we have to do before we can use it again? What sort of registrations have to be in place? What sort of approvals are required? In many cases, if you have a registration, as soon as you move the equipment, you have to re-register your device and get an approval. So your procedures should cover that sort of thing. Procedures should also document the radiation surveys that need to be performed. Are there surveys, regular measurements of radiation dose rates that need to be done? If so, what are you documenting? What sort of instrumentation are you using? Who do you have to report those surveys to? That should all be included in your procedure on surveys. If there's the potential for an emergency, then you should have procedures that document what people should be done in case of an emergency. Once an emergency started, this is a little too late to be writing this down, right? We want to have this done and ready for people ahead of time. And the emergency procedures should be shared with all personnel who may be working in the area of the X-ray equipment, not just with those who are responsible for using the equipment. There's also a requirement that we should have to see what we can do to make sure our program is functioning well. So we should have an indication in our program of what sort of oversight or audits are required, whether it's just an internal audit or whether we become more formal and have an external company come in and do an audit. We should document what our requirements are for our internal or external audits and how often they're done, who the results are reported to, what do we report if we find that we're in non-compliance with something. And finally, we should have a procedure on what the heck we're going to do with our equipment when we don't need it anymore. So how are we going to transfer it or dispose of it? What notifications are required? And this is quite important. If you've registered your equipment, your procedure should clearly state who you've reported or registered the equipment to and how do you, quote, unregister your equipment with your regulator, for example, so that they can take you off the list of those who have X-ray systems in the province. What you don't want to have done is to dispose of your X-ray equipment, don't inform the regulator, you haven't kept those records because you didn't have a procedure, and then the regulator comes to do an inspection and says, well, you didn't tell me you disposed of it, where is it? You need the procedure that tells you what records you keep, who you inform, that sort of thing. Our X-ray safety program should also talk about the instrumentation that we're using. So what sort of instruments are we going to use? We can't detect radiation ourselves. We have to use instrument to detect it. So our X-ray safety program should document that we have the right type of instrument. And depending on the purpose of the survey that we're going to do and what we're wanting to measure, we're going to use a different type of instrument. And we may be regulated in some areas as to a specific survey that has to be done or a specific dose quantity that needs to be measured. For example, some regulations limit the exposure rate in milliröntgen per hour or might use air kerma, whereas other areas might allow us to measure in dose rate. So we're going to have to understand the type of survey that we're doing and the purpose of it in order to make sure that we get the right equipment. And then the other things that our procedures with respect to equipment should do is should ensure that our equipment is functioning properly. So it should document that we have to calibrate our equipment, how we're going to calibrate our equipment, and the frequency. And best practice is to calibrate our radiation detection equipment at least every 12 months. Anytime there's a potential fault in the equipment, then those should be fixed or at least tagged out of service so nobody's using a faulty instrument. And our procedures should document what sort of function tests are done to our instruments prior to each and every use. Because we can't sense the radiation ourselves, we're relying on our instrumentation, and we should have a clearly documented process that we follow every time we're going to use one of those instruments in order to make sure that that instrument is functioning properly. So at minimum, we should be doing a visual check of the instrument. If they're battery powered, a battery check, because if the battery fails during use, we're not going to get the information we need from our survey, and we might put ourselves in an unsafe situation. When we're using our instrument, we should have a verification that it's in calibration. So we're going to pick it up and look at the calibration sticker and make sure that it's in calibration. And we should do some sort of a response check. So we're going to put our instrument near a radiation source, our X-ray machine or a check source that we've purchased to make sure that the instrument actually responds. Because if it doesn't respond, we don't verify that it responds, then when we go do our survey, we may think we're getting a 0 result when in fact the instrument simply isn't functioning. So we need to make sure that that instrument is functioning before we actually use it. The next part of our X-ray safety program that I wanted to discuss today is dosimeters. So a dosimeter is a device which is used to measure the total radiation dose over a particular time interval. And dosimeters can actually be purchased to measure radiation dose for various quantities, including X-rays, gamma rays, neutrons, beta radiation, other types. So our program should document the type of dosimeter that we want to use to make sure that it's suitable for our X-rays that we're using in industry. Dosimeters come in a couple of different forms. The most common one that we would use in the industry would be a whole body badge type. So this is something that we would wear on our body, perhaps on our chest pocket or a lanyard, that's going to measure the dose to the whole body from the X-rays that we're working with. There's also the potential to have an extremity type dosimeter, which often is in the form of a ring. This is something that we would wear on our ring finger to measure the dose to our extremities, particularly our hands, if we were working up close and personal with the equipment. So if we're maintaining it and our X-ray beam is on and we're working close by, we may want to have a dosimeter that's measuring the whole body, but then an additional one to measure the dose to the hands. And the requirements for when dosimeters are needed and which dosimeters are needed are going to vary with jurisdiction. Some jurisdictions, some provinces will say that doses are required based on the likelihood of a dose for a particular year. So for example, in Ontario, people need to wear dosimeters if there's a likelihood of getting 5 millisieverts or more. However, other jurisdictions may specify different requirements that are occupation-based. So for example, radiographers in healthcare, although I know this isn't a healthcare talk, but it may specify that radiographers and X-ray technicians in hospitals have to wear dosimeters or other types of occupations. So depending on the jurisdictions that we're working with, the requirements for when you have to wear a dosimeter may vary. Most jurisdictions who do require the use of dosimeters don't provide requirements on the dosimeters themselves. They generally reference our federal CNSC or Canadian Nuclear Safety Commission and say if they're registered or certified by the CNSC, then they're suitable for use for monitoring doses with respect to provincial regulations. Our procedures should be quite clear in our X-ray safety programs as to how dosimeters are worn and when they need to be worn. So for example, if you're working in areas A, B, and C, you do have to wear a dosimeter, but in D, E, and F you do not. And it should document how the dosimeter should be worn. So if it's a whole body dosimeter, it should be worn on the front of the body that's facing the radiation source and be worn between the waist and the neck. Our procedures should indicate, we have our own individual dosimeters. We're not sharing them. We're not going to wear somebody else's. We're not going to open them up. We're not going to intentionally put them in our X-ray beams or systems. And what to do if our dosimeter is lost, right? If the dosimeter is lost, we're no longer monitoring the people's doses. What are we going to do about that? So the worker has to stop their work. Who do they report to get a replacement? And what process is the X-ray safety officer or the person in charge of the process, what processes are they going to have to do to estimate the dose that had been recorded by that lost dosimeter? Because if we don't find it, we no longer have the information that it was reading, and yet we still have a requirement to measure and monitor worker doses. So those should be included in our X-ray safety program. Extremity dosimeters, if we have to wear them, do we have to wear them on just one hand or both hands? Depending on the type of work that is done, we may be okay just wearing the dosimeter on the dominant hand, or we may be better off having one on each. As with the whole body dosimeters, we don't want to share extremity dosimeters. It should be one dosimeter for one person and that sort of thing. Important to our program, whoops, what happened to my storing? There it is. Important to our program, dosimeters should be stored in a holder or rack when they're not in use. So they should be in a low radiation background area, in a place where people have easy access to them, and in a rack for easy notification and easy placement back into the rack. And it is good practice to keep extra dosimeters on hand as replacements for lost or damaged dosimeters. In general, our dosimeters in Canada from our 3 licensed dosimetry service providers from the CNSC, they're not overly expensive, so it is not extra hazard to our funding in order to keep a few extra ones on hand in case ones get damaged or lost, or in case a new person comes in who has to wear one that we weren't aware of at the time when we ordered them. So it's good practice to keep extra dosimeters on hand as well. Our X-ray safety programs should also document what records we need to keep and how long those records need to be kept. So some of them we may only need to keep for a short period of time. For example, maybe we only need to keep certain maintenance records for 2 or 3 years after the maintenance is done, particularly if the maintenance is being done a couple of times a year. But other things like our registration records, our procurement records may need to be kept for a longer period of time. So things we need to document what we need to keep and how long include all of our documentation with respect to procurement, whether we've registered them, what approvals of our registration we've received, what work procedures we're following, and when those procedures are updated, we should keep copies of the new ones as well as the old. Our maintenance records, when was maintenance done, our survey results, so when we do a survey, what instruments did we use, who did the survey, what sort of records do we need to keep, and those we should probably keep as long as we're having our X-ray equipment. We should also have records on our worker classifications, so these are the workers who are classified as X-ray workers, for example, and when they were designated as such, and the records of how we informed them of it and that they gave you back the record that they were aware of being informed. It's very important to keep track of our worker training records and what sort of training validation is done. So if there's a training course and then there's a test, we should keep copies of that sort of thing. We should maintain and keep up to date a list of authorized users, and that should be kept in our records as who's currently authorized. And we may be able to have a program where every 5 years if we've updated them, we can get rid of our old ones, or we may want to keep them for a longer period of time. We should also keep copies of our instrumentation records, particularly our calibration records. So if we're doing surveys with instruments, what are we doing to make sure that the instruments are reading correctly? And that's an important thing to keep a record of, so that if something was to happen later on, we can show that the survey that we did, at least at that time, the instrument was functioning properly. If we do have dosimetry, we have to keep our results. How are we going to keep them? How are we going to report to workers or regulators what doses were? Whenever there's an incident, we should do an investigation and keep a report of it. So that report may have to be reported to the regulator, but it's definitely something that we should be keeping on file. If we do have internal or external reviews or audits, we should be keeping those. It's one thing to say, oh yeah, I did my investigation, everything was fine. If you don't have a record of it, basically you can't show that you did it. So if you keep a record of what questions you asked yourself, what records you reviewed, that sort of thing, and you document it and keep that, then if the regulator has a question, it's easy for you to show that it was done. And then again, if you're disposing of equipment, keep records of what you've done. So where it went, what you did with the documents, what you did with the X-ray equipment, fact that you've unregistered it with your provincial or territorial counterpart if registration was required. All of that sort of thing should be kept as a document so that you have the records, if needed, to talk about your program. Alrighty, so that is the end of our slide presentation today. I've lost my questions thing, so just a moment here while I figure out how to get back my question log so I can see the questions that you've asked. There we go, questions. Where did my questions go? There it is, okay. I've got the questions back again. So if you have questions that you want to ask, please feel free to enter them into the questions section. Before I do proceed with the questions though, there are a couple other polls that I'd like to run. We're interested to hear how you actually heard about our webinar, so I wanted to ask you that today as well. If you could fill in for me, please, how you heard about the webinar. It looks like most of you heard of it from an email. A couple others had a recommendation from a friend. Excellent. Perfect. Thanks so much. And I'll just share those results with you for your interest's sake. And a few found out in a different way. All right. And we're also interested in where you are and what you work in. So we have a poll here about your location. If you tell us where in Canada you're from, or where you are if you're not in Canada, that'd be interested to us to hear. Excellent, thanks so much. So it looks like we have a lot of people in central Canada, but some from the east and some from the west, so that's awesome. We didn't manage to drag anybody in from out of country, but that's okay. We're the Radiation Safety Institute of Canada. We're happy just to be helping out Canadians. And finally, I'd like to ask you all, if you don't mind, what industry you work in. Do you work in food processing, some sort of manufacturing, in the research sector, in security, or in something else, because I was only allowed to put 5 up on the polls. Excellent. Thank you so much, everyone. It looks, I'll share this with you, it looks like almost half of you are from other groups that I couldn't list all the different options. Manufacturing is the next largest group, and resource sector follows that. So that's excellent to see. Thank you so much. Okay, I see that a few people have entered questions. So the first question I have here is, somebody is located in Ontario using only cabinet X-ray systems. They are using dosimeters from the National Dosimetry Service of Health Canada and never have had any recorded doses in 8 years. They've gone to a radiation meter with an audible alarm that runs all the time and is calibrated every 12 months. Is that accepted? So I think the question really is that going to be acceptable from a radiation protection program under the Ontario Health and Safety regulations? And I believe the answer would be yes. If you're not seeing any recorded doses for people who have been wearing dosimeters and doing the work in 8 years, you've pretty much shown that your dose for your workers is not going to exceed the level at which Ontario requires dosimeters to be worn by people. And you have the extra added feature of a meter in place that's going to let people know if there's something out of the ordinary going on. So that should be acceptable. So thank you so much for asking that question. If you do, by the way, have any further questions and you need clarification for any of the questions that we answer for you today, please don't hesitate to send us an email after the fact and we'll follow up. All right, another question that had been asked was with respect to cabinet certification. So a question was asked about X-ray instruments that you have. It says you need to build or design cabinets for X-ray instrumentation, and the ministry has asked to have them certified. How would you go about doing that? Oh, that's a very good question. And it's actually not exactly straightforward. So in order to certify your cabinets, you're going to need to document, obviously, how they're built and have shielding calculations done to document what sort of shielding is required. So for example, in the direction that the X-ray beam is emitted, you would do a calculation for the primary beam and say how much thickness of lead do you need in that direction. If that beam can't be moved in other directions, then your other walls have secondary or scattered shielding or scattered radiation, and you would do a different calculation for the thickness for that sort of thing. And then you'd have to document it. The other thing that you should do as well is to make sure that your systems are meeting the Radiation Emitting Devices Act so that they've got the proper labels and things like that. So we can probably take this question offline to give you some more details, but that's sort of the process that you would need to go through. Okay, so somebody else here, Roxana, has asked with respect to a question with respect to calibration of X-ray machines. So the question is with respect to calibration. How often do X-ray systems need to be calibrated, and does this have to be part of the safety manual? I'm not entirely sure what you mean by calibration of the actual X-ray machine. So if you're talking about instrumentation and dosimetry, for example, a electronic dosimeter, that sort of equipment needs to be calibrated every 12 months, and that calibration is actually verifying that the instrument is reading your radiation properly and accurately. So it's giving a number for dose that's actually representative of what the dose is. For actual X-ray machines, depending on what you're using them for, may define what you need for calibration. So for example, if you're using an X-ray machine to measure thickness of a material, then your calibration requirements are going to depend on the use. X-ray machines can also be used for measuring quantities of elements. So an X-ray fluorescence system, for example, is going to tell you in metal, if you're doing metal analysis, how much nickel is present, how much gold is present, that sort of thing. And for that sort of thing, the typical calibration frequency would be annual. So for this, it's going to depend on the actual use of the instrument. So we can take that offline if you want. You can send us an email after the fact and we can answer that specifically for your use. So somebody has asked, what is the dose limit for dosimetry in Ontario? And I think you're meaning, what is the point at which a dosimeter in Ontario is required? And just give me a moment. I am actually going to go and open up the file that I have. I believe it is the 5 millisieverts per year. Let me just open this up here. Oh, my computer is not cooperating with me to get to that sort of thing. My apologies. I am pretty sure, and I can get back to you on this, but I believe it's 5 millisieverts per year. So if a worker is likely to get 5 millisieverts per year or more, then Ontario occupational health and safety rules require dosimetry to be worn. But we'll definitely verify that and get back to you, Layla. All right, Aaron has asked if there is a dosimeter that reads gamma radiation that is sufficient for workers that work around X-rays. Aaron, this is actually a really good question because the type of dosimetry that you use for X-rays is going to depend on your X-ray energies. And gamma rays have different energies and may not, dosimeters that are used for gamma rays may not actually be suitable for your X-ray system. So there definitely are dosimeters that read for X-rays and may often read for both X-rays and gamma rays at the same time. The best thing for you to do is to talk to your dosimetry service provider and talk to them about the energies of the X-rays that you're using and the energies of your gamma radiation so that you can make sure that they're providing you with a dosimeter that will meet both. Sometimes one chip is not going to be good for both. You may need to go to a dosimeter and have 2 chips inside one dosimeter pack. So one chip will be suitable for measuring lower energy X-ray, whereas another chip will be measuring higher energy gamma ray, and then you'll get a report on both. So you can get dosimeters for both purposes. but it's going to depend on the energy. Okay, May has asked for cabinet x-rays, what sort of training is required and what sort of frequency of training is required? It is going to depend somewhat, May, on your cabinet x-ray system. Generally speaking, people who are using the system are going to need more training than people who are simply working in the area around the system. So people who are using the system need to be trained on what sort of hazards the X-ray system possesses. So, you know, the fact that it emits X-rays, how X-rays interact with people and the risks of that. Explain the risk of the more dose you have, the more risk of cancer, that sort of thing. They also need to be trained on the proper use of the equipment. So what is your procedure for operating it? What are the controls for the system? How do you shut it off if you think there's a problem? How do you know that it's working properly? That sort of thing. People who are working in the area don't need quite as much detail of their training. They need to understand that the X-ray systems are there, a little bit about the hazards and who to go to in case they have a question, but that in general, because it's a cabinet system, there really are no hazards outside of the system. So the training depends on whether or not the people are working with the system or not. Someone here has asked, where can I get dosimeters in Ontario? Actually, there are 3 dosimetry service providers in Canada who are certified by the Canadian Nuclear Safety Commission. Those 3 include Health Canada. Health Canada runs what is called the National Dosimetry Services, and they're based out of Ottawa. They will provide dosimeters. We also have 2 companies who are US-based but have authorization and certification to do dosimetry in Canada. That is Landauer is one of them, as well as Mirion Dosimetry. So they both have websites and phone numbers that you can call. If you want more details and you want us to send you an email of exactly how to contact these 3 suppliers, please do send a follow-up email to the webinar and we will send that out to you. Okay, Greg has asked whether if electronic personal dosimeters need to be calibrated annually. How about pen dosimeters? And yes, any dosimeter that you're using to monitor dose for people really should be calibrated on an annual basis, whether it's an electronic dosimeter or whether it's the old style pen type dosimeters. If we don't calibrate them on a regular basis, which is generally speaking every 12 months, we don't know that what they're measuring is a true representation of what the dose to people is. So you should be able to you should be getting your instruments, whether it's a survey meter or a dosimeter, whether it's electronic or not, calibrated every 12 years. So every 12 years, every 12 months. Sorry about that. Greg, thank you very much for your question. Another question here is, where can I purchase an X-ray contamination meter? I think you're actually you're asking the question of where can you purchase an X-ray survey meter. X-ray equipment, for the most part, is using X-ray tubes to create the X-rays, whereas radioactive material sources, that's when you're concerned with contamination. So contamination is a spread of radioactive material out of our source. X-ray systems, generally speaking, don't use that, so we don't have contamination. Then there are lots of suppliers for X-ray survey meters. So lots of survey meters are made by different manufacturers, and there are a few there's multitudes of companies out there. So Ludlam manufactures some. I could give you a whole list. Canberra manufactures some. I think it's going to depend more on what type of instrument you need and what you're going to use it for that will help narrow it down. So if you want to send us an email later, we can certainly have a discussion after the fact to help you out with determining what what survey meters that you would need. All right, that is the end of the list of questions that have been answered so far. Does anybody else have a question that they would like to ask before we sign off on the webinar? If you do, I'll give you a few more moments to type that in. Okay, we've got a couple more there. Do you get a certificate of attendance for the webinar? Unfortunately, we don't have a means to do that, so we cannot give you a certificate of attendance for attending this webinar. It really is intended more as an informational session than as a formal training mode. That's a very good question. We will look into whether or not we can do that for future webinars. Greg has asked what sort of PPE is required for handheld X-ray equipment. Greg, that really is going to depend on the type of equipment and how you're using it. For example, if you're using an X-ray fluorescence handheld meter to measure, let's say, contaminants, levels of different contaminants in the soil, generally speaking, very little PPE is required. This would be so long as you're making sure that the instrument is only turned on when it's pointed away from people, that sort of thing. If you're using a different type of handheld equipment where you need to use your hands to hold a sample, that would be a different type of situation, in which case you might, number one, try and use tools to keep your hands out of the beam, but then you might be looking at, for example, gloves or that sort of thing. So I think the type of PPE required is really going to depend on the instruments and what they're used for and how they're used. So it's unfortunately very difficult to answer that in this sort of open question. If you do want help figuring out PPE that's needed, certainly send us an email and we can follow up and help you with some of that. All right, we're coming up on 3:30, so I thank you all for attending our webinar today. We do intend, if the technology worked appropriately, to finish the recording and to post this on our website at a later date. And hopefully that will be sooner than later, but it is technology dependent. So, and sometimes technology is not our friend and makes it a little harder for us to get things done. Thank you very much to everyone for participating with our webinar for the Radiation Safety Institute today. Do let us know what you think of the webinar, and if you have any other topics that might be of interest, please feel free to send them along. Have a wonderful day, everybody, and I wish you all an excellent weekend. Thank you so much.